This video extends our concept of solving quadratic equations using the quadratic formula. So far up to now, our equations haven't had any fractions in them, and they've all been relatively easy to move around to get into the correct form. But the four types of equations that we're going to do on this video are a little bit more difficult. So let's start off with our first example. And we know when we solve a nice quadratic equation using the quadratic formula, we need to find our A, our B, and our C value. And the first thing I want you to notice is that we have fractions in this equation. So what I would like to do is I'd like to eliminate the fractions because I don't want my A value, my B value, or my C value to be a fraction. That would make things really difficult. So what I'd like to do is I'd like to multiply, use my property of equality, and multiply by a number that gets rid of all my denominators. So I know that 14, if I multiply by 14, that will eliminate this 14 and this 7 right here. So I'm going to distribute 14 to both sides of the equation, all my terms. So when I get 14x squared over 14, plus 14x plus 14 times 13 over 7 equals 14 times 0. My 14's here cancel out to get x squared plus 14x. How does this reduce? My 7 goes into my 14 twice, and 2 times 13 is 26. And anything times 0 is just 0. So that makes it really nice. Because now, if I take a look at my standard form for a quadratic equation, I have my A, B, and C value nice right there. And remember, when we don't have a number in front of a variable, that number is 1. So my A value is 1, my B value is 14, and my C value is 26. So let's review the quadratic formula. It's negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so let's go ahead and substitute our values in. We have negative times 14 plus or minus the square root of 14 squared minus 4 times 1 times 26 all over 2 times 1. And when I multiply that out, it's a negative 14 plus or minus 14 squared is 196. 4 times 26 is 104. So that's going to be 104 all over 2 times 1 is 2. And then when I subtract 196 minus 104, I get 92 over 2. So let's go ahead and factor 92. See if we can reduce that radical. I know 92 is 2 times 46. 46 is 2 times 23. And that makes it perfect because that gives me a group of 2 for me to reduce out. I can simplify that radical to 2 radical 23 over 2. And now if I look at all my numbers, they are all divisible by 2. So I'm going to divide everything by 2. Negative 14 divided by 2 is negative 7. 2 divided by 2 is 1. And then 2 divided by 2 is 1. Oops, I don't need my denominator because I don't need to divide anything by 1. And negative 7 and the square root of 23 are not like terms, so they cannot combine, so I'm finished solving for x. So now let's take a look at our next equation. Okay, again, this does not compare very nicely to ax squared plus bx plus c equals 0. So I could subtract 9, but I still don't have a squared term. So I think what I should do is I should FOIL. So x times x is x squared. Negative 4 times x is negative 4x. 9 times x is 9x. And 9 times negative 4 is negative 36. When I combine like terms, I get x squared plus 5x minus 36 equals 9. And then I'm going to go ahead and subtract 9 from both sides of this equation, and I get x squared plus 5x minus 45 equals 0. And that looks a lot better. It looks like we are in the correct form this time. So now I'm going to go find my a, my b, and my c value. A is going to be 1. It is missing, right? When it's missing, it's 1. B is going to be 5, and C is going to be negative 45. So when I go and I solve using my quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a, I am going to plug in my values using parentheses. 5 squared minus 4 times 1 times a negative 45 all over 2 times 1. And when I simplify, I get negative 5 plus or minus 5 squared is 25. And I get 4 times 1 is 4 times a negative 45. That's 180, negative 180. And I know that a double negative is a positive. So when I reduce this and I actually add those two numbers, I get 205 under my radical. Okay, so how does 205 factor? Well, I know that 5 goes into both. 5 goes into it because it ends in 5. So 5 times 41. 41 is prime. Thank heavens I don't have to try and do that. All right, so here we go. We have 5 times 41. Nothing goes into 41, so we don't have any groups of 2. So I end up with negative 5 plus or minus the square root of 205 all over 2. Negative 5 and the square root of 205 are not like terms, so I'm going to leave it as that. And that is my answer for x. All right. How about this example? Again, this is nowhere near my ax squared plus bx plus c equals 0. So I think what I need to do is distribute this x and see what that gets us. Well, I got x squared minus 6x, but now it equals 8. It doesn't equal 0, so I need to subtract that from both sides. And I get x squared minus 6x minus 8 equals 0. Now that looks a lot better. Ax squared plus bx plus c equals 0. All right, so now it's time to find our a, b, and our c values. A is going to be 1 because our leading coefficient in front of our x squared term is missing. B is going to be a negative 6. And c is going to be a negative 8. So when I use my quadratic formula, negative b plus or minus b squared minus 4ac all over 2a, I am going to plug in using parentheses. Okay, so I have negative 6, and I'm going to square that. 4 times 1 times negative 8 all over 2 times 1. When I reduce that, a negative times a negative is a positive 6. Negative 6 times a negative 6 is a 36 minus, what's 4 times 1? It's 4 times negative 8 is a negative 32. Okay, so that means that is going to turn into a positive, and 2 times 1 is 2. So when I add those numbers, I get 36 and 32 is 68 over 2. And how does 68 reduce? Well, I know 68 is 2 times 34. 34 is 2 times 17, and 17 is prime. And that gives me a nice group of 2 2's. So that simplifies by pulling a 2 out. And then I want you to take a look at all my numbers. They all reduce by a factor of 2. So I'm going to divide each of these by a factor of 2. And I get a 3 plus or minus 1 radical 17 over 1, which I don't need to divide by 1, so I'm going to erase that. And I look and see that 3 and radical 17 are not like terms, so those are my solutions for x. And then this is going to be my last one before I start up a new video. Alright, so I know I need to find a, b, and c, but it's quite clear that I don't have, I don't have my equation in standard form. So I think what I need to do is I need to distribute. So x times x is x squared. X times -1 is negative x. -3 times x is negative 3x. And -3 times -1 is a positive 3. So when I combine like terms, I get x squared minus 4x plus 3 equals 8. But my equation still doesn't equal 0, so I need to subtract 8 from both sides. So I get this as my equation. So now I can easily find a, b, and c. So a is going to be 1, because when I'm missing a coefficient, it's 1. B is going to be -4, and C is going to be -5. And my quadratic formula is -b plus or minus b squared minus 4ac all over 2a. And I always substitute using parentheses, plus or minus -4 squared minus 4 times 1 times -5 all over 2 times a. And a is 1, and double negatives means it's a positive. If I square a -4, I get a positive 16 minus 4 times 1 is 4 times -5 is a -20. All over 2 times 1 is 2. Our double negative reduces. And when I combine my terms under my radical, I get the square root of 36 over 2. And I know I can factor 36 into a perfect square, 6 times 6. So I have a nice group of 2 6's there, so I can reduce that radical to 6. And I know that 4 and 6 are like terms, so I'm going to split it up. For one answer, I'm going to do 4 plus 6 over 2. For another, I'm going to do 4 minus 6 over 2. Well, that's going to be 10 halves, or 5. This is going to be -4 halves, or -2. So my final answers are going to be -2 and +5. Okay, so the next topic that we're going to look at on our next video is going to be number and type of solutions for each of the quadratic equations, because it would be nice to know what kind of solutions we're going to get.